To be looking at performing the write operation onto 6 transistor static RAM cell. In a previous segment, we looked at the cell setup or cell structure and how to perform the read operation. We will now be seeing how to perform a write operation. So while performing the write operation, first of all, we need to remember that the bit and bit complement act as input lines. So in our previous case where we did the read operation, these two in a sense helped us identify the output. So they acted as output lines there, whereas here they will act as input lines. So this is something we need to remember. Now to write, these are the steps. Step 1, set write line as 1. Step 2, charge capacitors fully. These two were again steps we performed even when we were writing. WL is set to 1 so that the access transistors are turned on. That indicates that any operation to be performed is going to be performed with respect to this cell out of an array of similar cells which makes up your memory. And the capacitors are charged to their full capacity. These are common to reading and writing. Step 3. Let us assume the current value stored is a 0 and I want to write the value 1. So Q, right now let's assume it has a 0 and I want to write the value 1 onto it. So this is the example case I am taking. Even if you take the opposite case where Q is currently 1 and the value to be written is a 0, it will work equally well. So once you know the logic, I would encourage you to try that one out as well. So now Q is currently a 0, Q bar is a 1. I want to write the value 1. So I set bit equals 1 and bit complement equals 0. So whatever value I want to write, I will set that as bit and its complement at bit complement. Fine. So that was step number 4, bit equals 1, bit complement equals 0. Step number 5, V equals VDD at M6. So at this point the voltage equals VDD. VDD is the maximum charge that this capacitor can hold. So at M6, because this capacitor is fully charged, this voltage is maximum. Whereas bit complement is 0, so this line has no charge or it is a low. So this part is a high, M6 is a high and this capacitor is high, fully charged. This line is, on the other hand, it is low because it's a 0. What happens because of that? Charge flows from C2. So this charge of C2, which is associated with this transistor, starts flowing into this bit complement line to bridge this potential difference. So the voltage at M6 starts decreasing. So let me repeat, C2 is fully charged. So the voltage associated with M6 is high, whereas the bit complement line is a 0, so the voltage associated with this line is a low. So to bridge this potential difference, the charge from here starts flowing down this line, meaning the voltage associated with M6 is going to decrease. It starts falling, and when the voltage at M6 becomes less than the threshold voltage of M2, M2 becomes off and M1 becomes on. Now if you look at the circuit, M6 is connected to M2. Similarly, M5 is connected to M4. So this transistor is connected to this one, M2. And this transistor is connected to M4. Now we saw that the voltage at M6 is dropping gradually. And each of these transistors has its own threshold potential, which is like a limit potential. I need a minimum of this much potential in order to be switched on, sort of. So M2 has its own threshold potential, and when the voltage across M6 drops less than that threshold, we say M2 is switched off and its complement M1 gets switched on. That is what is written here. When the voltage at M6 drops below the threshold of M2, M2 gets switched off and M1 gets switched on. Once M1 has been switched on, the data which is stored in the bit, it travels through the bit line through M5 to M1 as the input. So the input we are giving at Q becomes a 1, and that is how we write a value. This 0 changes into 1. Q is equal to 1 now, and once your Q has become a 1, automatically your Q bar becomes a 0. So that is what is explained here. I'll give you a quick recap. Take a quick look at the steps. We go back to the circuit and we'll see. Now step number 1, set the write line as a 1 to indicate that this cell is selected. Step number 2, charge the capacitors fully. Step 3, assuming that the current contents of Q are 0 and I want to write 1. So I set 1 as bit and 0 as bit complement. Now here, because this one is charged fully and this one is a 0, meaning no charge, to bridge this potential difference, charge from here starts flowing here, meaning the potential associated with M6 is going to decrease. And each of these transistors has its own threshold potential, which is like the minimum potential required to function. So because M6 is connected to M2, when the potential of M6 starts falling, the corresponding potential of M2 is also falling, and when that falls below the threshold of M2, M2 is switched off, M1 is switched on. When M1 is switched on, the bit from here travels through M5 through Q into M1, and that is when Q becomes 1, which is what we wanted to do. We have written 1 into Q and immediately Q bar flips into a 0. Now the other case, if Q is currently a 1 and if I want to write 0, there are very minor changes. Q would be 1, Q bar would be 0, current state. I want to write a 0, so I make bit 0 and bit complement 1, in which case this is fully charged and this one is low, so charge flow happens from here to here. This one's potential starts reducing and M5 is connected to M4, if you can see. So when M5's potential reduces, M4's potential will also reduce. When it falls below the threshold of M4, M4 is switched off, M3 becomes switched on. Then this 1 travels from the bit complement line to M6 to Q bar to M3. Thereby Q bar becomes 1, and when Q bar becomes 1, Q is obviously set to 0. So that is how you perform a write operation on an SRAM cell.